And also microphones are very sensitive. Please don't do slurpy drinks and talks. So the people online will not be disturbed. So welcome everyone again. Dr. Rasheed worked with me previously at our previous institution. That's how I know him, but currently he is working as a senior lecturer at Smart Internet Lab at BDFI. He mainly works on network and cybersecurity, digital twin security, and responsible AI, including fairness in AI and explainability. He also serves as ACM Distinguished Speaker. Today, he will be talking about the role of digital twin technology in cyber and network security and how digital twin will contribute to the security or insecurity of digital system and infrastructure. As I said, for people at home, we have turned the chat off during the presentation, but we will turn it back on for the Q&A session later. And thank you.
Thank you, Alma. Hi, everyone. My name is Rasheed Hussain. Thank you so much for coming. And also, thank you so much for joining online. Today, I'll talk a little bit about digital twin, demystified, talk about some misconceptions that we usually see in the area of digital twins, but my focus will be mainly on cyber and network security. So this is the main outline of my talk. I'll leave the question and answer for the end, but if there's some burning question that you really need to ask, then please stop me and then we can talk about it. So I've divided this presentation to mainly three portions: the what, the why, and the how. So the what is, it all started in 1970s, if I remember correctly, it's 71 or something. How many of you have watched this movie, Apollo 13? Great, then it will be very easy for me to. So what happened is that this Apollo 13 mission to the moon, and not halfway, but near to moon, they got some problem with oxygen tank. So the oxygen was leaking, and they were in a very difficult position where they couldn't go to the moon and they couldn't come back because they didn't have enough oxygen to land on the moon or come back to the Earth. So what they did at that time in 1970s, the technologies, of course, were not, digital technologies were not that advanced, but they had the exact replica of the physical ship. So there was a pilot or another member of the crew who was not selected, but he was equally trained. So what they did is that they tried to mimic the same situation with oxygen tank on the ground and see how they could solve that problem. And when they figured out how to save the oxygen, so for them to come back to the Earth safely, they tried to, they tried everything with that physical replica. And they coordinated with the crew that was strangled in the middle of nowhere, and they made it back to Earth safely. So the key point here is that physical replica that made them to do whatever they do, the what if scenario. What if we had leak in the oxygen tank? What could we do to make things right and make things safer? Then coming decades after, there's a term coined by a scientist, digital twin. So it is nothing more than a digital replica of anything. That anything could be, so there's so many definitions, I won't go to the definitions. There's some terminologies that are really important to understand, to really understand what exactly digital twin is, because we are in the middle of standardization efforts towards digital twin technology, and it's really important to understand what exactly this is. So here you can see this digital model. It exists already for many, many years and even decades, where we take a scenario, we take a behavior, or we take any problem and we use artificial intelligence or any other technology to make a digital model. And here you can see the manual data flow. So if the process of making that model includes manual data flow, then we just call it a digital model, and we can have a physical asset there. The second one is, what if this data flow is from physical asset to the digital model? What if that is automatic? And then this other connection from digital world to the physical asset is manual. Would that be a digital twin? No, it's called digital shadow. We call it digital shadow. And the third one and the final one is where both ways we have automatic flow. I'm being careful with the data because there could be data, it could be information, it could be knowledge, it could be anything that flows between these two components. So the real digital twin, if we want to call it digital twin, is that you have physical asset. That asset could be a component, that could be a whole system, that could be behavior, that could be an environment, whatever you call it, but then you have a digital replica of it. I mean, how familiar that is, we'll talk about in a moment. So is the hype real about digital twin, especially from cybersecurity perspective? National Cybersecurity Center, NCSC, is working very, very extensively on using the capabilities of digital twins to secure the system. But of course, it's an ongoing work and we don't have anything tangible yet. I'll quickly go through the major applications for those who don't know. For example, in manufacturing, Rolls-Royce is the big example of using digital twins. Airbus, Boeing, they use digital twins for aircraft design, operations, and all those things. In automotives, Volvo, they're trying almost all the. So I'm mentioning Volvo here because they're very prominent in other manufacturers. They're also using it. There's so many, of course, challenges with this. The challenges we'll talk about in the end as well, but from the security perspective, GDPR, CCPA, and HIPAA, and all these are major, major concerns, because when we talk about sharing the data between physical and digital, we usually ignore the fact that the data could have so many attributes that could be privacy sensitive. So that's why that should be considered, and there are ongoing work on those fronts. Legal and regulatory issues, as I said, is still very extensive ongoing work. And from the organization challenges, of course, we have skill set and cost of having these kind of infrastructure as well. Technical challenges, which I'm going to talk about today, are the data accuracy and equality, how to integrate between digital and physical, and how these systems, they will interoperate. And of course, how do we make them scalable? One of the examples we have here is reality emulator as well. Going to other application domain, we have constructions. The Elizabeth line is actively using digital twin, and Crossrail, they're also using digital twin as well. Offshore oil and gas companies, Shell, for example, they're using digital twin to optimize their production of the oil and gas. And one of the interesting ones is Digital Heart by University of Sheffield. They have a project, they're still working on it. So what they're trying to do is to model a digital twin of participants' heart from their health data, and over time, and it's actually ethnographically informed data to form the digital heart and work on diseases, future diseases, existing diseases related to heart and so forth. So it's actively researched these days. In other domains, for example, transportation, retail, and smart cities, there are numerous examples of using digital twins. But one thing that is common among all of them, except the digital heart, is that we don't know exactly how they work, because these are very commercially adapted solution that we don't have access to, so we don't know how they are designed and how they work. Now, what they can do, digital twins, from the technology perspective, of course, I'll be looking at it from network and system perspective. We could use it for resource optimization. We could use it for sustainability, for security and training and analytics and situational awareness, risk assessment, predictive maintenance, and visualization. So all these are the areas that are prominent and actively researched in digital twin. So what are the building, now coming towards making digital twins, how exactly do we make digital twins? There are a few things that we need to take into account. First is identifying what kind of assets do we have, whether those assets are tangible, whether those are non-tangible. Intangible, for example, we can have a product, we can have a sensor, we can have a bunch of sensors, we can have another component, any component inside your computer system, and we can have the entire system sensor network, for example. In non-tangible, we could have a service, we could have a process, and we could have an event about which we are not sure and we want to make a digital twin of it. Now, there's numerous data sources as well. So we could have sensor-based data. We could get the readings from the sensor. We could be very domain specific. We could have, for example, temperature-related data. We could have humidity-related data. And we could be contextual. So the data that is provided to model the digital twin could be contextual. It could be a history of the system. It could be some other instances of digital twin that we could use to scale the current digital twin. And you could have a reference digital twin with which you can do evolution. Then the other important thing is the life cycle. So whatever component, whatever asset you consider, for example, a system, you need to think about what is the life cycle right from the beginning, right from the thinking stage, all the way to its retirement. So you have to think about all these life cycle phases to model a digital twin. Now, to model it itself, it could be both data-driven or physics-based, where in some cases we know the physics behind how systems work. In other cases, we don't. So we take the help from the data to model those twins. And then the most important part is the front end. So what exactly do you want to do with digital? It's not only making the digital twin. At the end of the day, we need to do something about it, whether that is predictive analytics, whether that is making informed decisions, whether that is doing some kind of predictions or doing security analysis or awareness or training or all these kind of things that can be done with digital. So the front end is extremely important as well. Now, there are different requirements. I'll quickly go through them. The first one is trusted data acquisition and dissemination. Imagine you want to make a digital twin of a sensor network and your sensor is rogue, it is malfunctioning or something like. How do you make sure that the data you get from the system is trustworthy, is healthy, without which no matter what kind of model you design will malfunction and the end result that you want from this will not be valid. Tampering, if somebody, adversary, if they happen to tamper with the data, then exactly that is a problem as well. So for the integration and interoperability, of course, we would have multimodal data. I mean, it shouldn't be based on single source of data. It should be multimodal data. And third one is to contextualize, to generalize. The fidelity of digital twin is extremely important. How much fidelity, how much resemblance do you want with your physical twin and your digital twin? That is one of the parameters that should be really, really considered. And the next one is maintainability and manageability. For example, of course, you need to have resources to do these kind of experiments. And memorization is related to short-term data and long-term data. How long do you want this digital twin to exist? If it is long-term, then you really need to think about how to channel the data between your physical asset and the digital twin, and how you can make redundant system that upon failure, they are able to cope with all kind of situations. So APIs and libraries, for the people who know about the technicalities of this, and operation modes, simulation, replication, that I will talk about in a moment. And also, we have to think about the computation and communication performance as well, of how well these digital twins perform. Now, they're mainly, when we talk about digital twin, there are two things that we have to take into account. First one is the simulation mode, and second one is replication mode. What digital twin gives us is the capability of doing simulation inside an environment that mimics the real world. I mean, if you're doing simulation without any context, means that the reproducibility of those, or doing what if scenarios, what if this, then, what if that, then, these kind of scenarios are very difficult without taking into account the context. So for that, inside digital twin, we can run as many simulations, and we can reproduce as many as we want. Second one is the replication. So replication is it's more challenging because it needs synchronization between your physical asset and digital twin. Imagine a system where your system state is changing every microsecond. Then you can understand and you can appreciate how difficult and challenging it would be to synchronize these physical and digital. And this should be done at the same level at which the change is happening, the change in the state is happening. It's not a religious rule, but based on the underlying service and application, this could be very much valid argument and requirement. So how can we use digital twin for cybersecurity or digital or network security for that matter? The first one, digital forensics. So forensics is the field that I'm talking about, these are not new. But digital twin is giving them another shape, and it making us rethink about how the security should be provided to systems. Intrusion detection, again, intrusion detection, we have this intrusion detection for decades. But what digital twin brings along is a very rich set of features that we could use to intelligently work on digital twin. Testing and training means if you have a test environment, there are two ways. Either you have to replicate or have a test bed for your entire infrastructure, or what you can do is that you can create a digital twin and let it be your testing sandbox where you can do all the experiments you want. Cyber deception, one of the security features or security elements that we can think of is deceptive security, where you know that it is inevitable for the attackers to attack the system, as we have seen and learned. I mean, no system is 100% secure. That's the very baseline of cybersecurity. So how can you make the attack late and engage the attacker in an activity that could at least delay the attack? So cyber deception is one of them. And also, last but not least, threat intelligence means that you get all kind of information from the sources that you have and the knowledge that you can gather, you can scrap, and then what you can do is that you can make intelligent decisions or informed decisions based on the information that you gather. So these are the few, but there are a lot more as well. So the why would we, again, in the presence of existing security solutions, why would we use digital twins? As an example, if you consider cyber-physical system, then the consequences of information technology versus operational technology, there are always consequences. The consequences of these two are the combination of these two, operational technology, information technologies, are always cyber attacks. And why? Because the operational functionality, it always, I mean, historically, it always outweighs security. I mean, security has been always an afterthought. We do have the security by design concept for the last decade or so. And now, in real senses, digital twin can enable us to think different from security by design. And second one is that the loopholes in the infrastructure, they enable attackers to launch different kind of attacks. Some of them, for example, 0 days, they're not even known in advance. So that makes it more challenging to cope with these kind of attacks. And third one is the absence of trustworthy data generating sources, where we are not sure whether the data that is generated by these sources is trustworthy, whether the source is trustworthy, whether the data is trustworthy or not. So we have to think about them. So digital twin could be a really well informed and well sorted out technology to rethink about the security aspect. Now, how this evolution craft happened across years, if you start from 2010 all the way to 2021, and I could go further into 2022 and so forth as well, these are the very well-known attacks, starting from Stuxnet all the way to the water facility attack that happened in 2021. Triton is a very famous one. Indestroyer is the one from, I guess the Indestroyer is from, yes, Ukraine. And there's a Triton, Emotet, and all others. So this Emotet is also a very famous one on some manufacturing plant. So there's one thing common among them is that most of them, they were dormant, especially in case of Stuxnet. Means that the virus or the attack was so intelligent that it was there in the system for years and years and looking for the opportunity to launch itself. So in order to combat these kind of situations, we need to have solutions that are equally, if not more, intelligent as well. So existing solutions, for example, for intrusion detection system that I talked about, the problem with them, with existing solution, is that it's very hard to reproduce these attack scenarios. It's really hard from technical perspective. Second one is test beds. As I said, we can have test bed, but they are really expensive, both from time and cost perspective, and it's very hard to maintain them as well. And then it brings up the limitation of having countermeasure, but they are very delayed, and the damage has already been done. And it does not cover the entire life cycle of the product. It focuses on, so the solution we have, they focus only on a particular segment of a system and not the entire system. But the real question is, how about securing digital twin themselves? If we are using them as a security enabler, of course, then securing them is equally important as well. It is why? Because of the GIGO problem, garbage in, garbage out. So you cannot expect more than that. So security through digital twin, if you're using as in security enhancement enabler, then it should be really important to consider the security of digital twin as well. We did some experiment that I'll talk about in a moment, But with time, there are different, for example, hybrid attacks that could happen both in physical and digital. And the problem with digital physical continuum is that it makes it sort of easy for attacker to attack, not from one. Before you had this physical security requirement, but now you have to be sure that your digital infrastructure, which is the replica of your physical, is also important. Because if you remember in the beginning, I said that automatic data flow and information between physical and digital, if that is the real scenario, then you should be really worried if the attacker attacks from the digital side or from the physical side. It will affect both of those, unless and until you have something to stop the attacker. Now, the data inconsistencies, it's really important. In our experiments over the last 3-4 years, what we tried is to create these inconsistencies and see how do they play out with the underlying service that we are providing. So it's really important to think about these inconsistencies as well. Then I'll discuss a little bit about abuse cases. The first one is information leakage. So digital twin, it brings along, from my experience, it brings this trilemma. If you're trying to safeguard information and you have fidelity and then you have representation. So you're stuck between this triangle in order to decide on what exactly is the best path for you to select from all these. Okay? This is specifically very valid for cyber deception as well, but information leakage in major terms, it's really important factor to consider. Second one is the bidirectional cascading inconsistency. As I said, if you have your physical and digital, what you can do is that since these systems are connected, all you need to do is to have one. So what we call in networks is the security of your system is as good as your weakest link, right? So all you need to do is to capture one weakest link, and then you can have cascading effect throughout. So how digital twin can be secured through, how digital twin can be, how digital system can be secured through DT. Then in that sense, if for some reason you don't have access to your physical infrastructure, or you don't want to disturb the operational system, the corresponding digital X, whether that's shadow, whether that's model, that is twin, is the next best thing, because you don't want to be left to chance. Nothing should be left to chance, and you should do informed decisions before something bad happens. So digital twin can provide us with the tailor-made solution. You can focus on one particular system, and you can then focus on automating this security measure. You can adapt it to any domain that you want, and you can focus on accuracy as well. We talked about intrusion detection before. So intrusion detection systems, they have many false positives in reality. But with the context, if you use that to a particular context inside digital twin with running hundreds of scenarios, you'll be able to classify your traffic or the attacks in a much accurate way rather than with the existing systems. Enigma is one of the work that we did before. It's gamifying cybersecurity games between physical and digital. So what we did, it is a very complicated figure, but I'll try to make it easy. We call it secure digital twin through gamification approach. What we did is that we, in cybersecurity, what we call is red and blue teaming. So we make red team, blue team, and they, so red team try to attack and blue team try to safeguard. So what we did the same thing with AI models inside digital twin. So we use cyber physical system of an assembly line where vehicle manufacturing assembly is there, and we try to introduce attacks from AI model with the data and another AI model we use to safeguard and try to safeguard, number one, and first try to identify the attack vector and then try to do something that could safeguard it. And then we try to explain it as well. So we made it a gamification platform. We implemented it in Microsoft Azure Digital Twin platform, and these red and blue team, we were able to instantiate a game between these AI agents and try to at least look into how the system reacts if we try such thing with digital twin. Second one is second work is what we call triple, which is trusted and intelligent cyber physical system, where we use digital twin blockchain and threat intelligence in parallel. Again, these are very complicated figures. I wouldn't go into the details, but the crux of this work is that I talked about data inconsistencies. So in order to make data consistent, we rely on provenance. Before making any model, we make sure that the provenance of the data and the source of the data is intact, is healthy. Only then we try and make the model. So we do that by using blockchain technology, by putting the important aspects of data and provenance in the blockchain. So before making the model, we try to use blockchain to verify at least that the data sources that we use are they're healthy. Last one is inception. We use inception as a deceptive mechanism where we try to learn attacker behavior. When we learn what the attacker wants, we try to generate digital twin on the fly and give it to the attacker to attack it, to keep it engaged. But it brings problem that you don't want to give away the information about your infrastructure if you're giving such digital twin. So the orchestration of this deception is extremely important, and it's still an ongoing work. For now, there's another work that does the exact same. So this is what we call cyber kill chain. This cyber kill chain was mimicked inside digital twin to make the attacker busy. It means the attacker should be able to identify whether it is attacking the wrong system or the right system. So that's the main aim of having this deceptive twin. Cyber ranges are really important aspect of digital twin, where you can use this for training of employees, training of different security architect and so forth. So we used that gamification platform that I mentioned as a cyber range. There are plenty of use in telecommunication systems as well, but I'll just go through what we are doing in Smart Internet Lab. This is the important bit. So what we are currently doing is we are making, and we have made already, but trying to make up more services on top of it, is the digital twin of intelligent controller inside network that will be the driving force for 6G. So what we're trying to do is to make a platform where any service provider can come and bring their own solutions, for example, energy saving solutions or mobility solutions, and they can test it on our platform. Means that we can provide them with the data from our real network, with the synthetic data generated inside digital twin from different simulators, and then they can do the prediction, they can do performance analysis, they can do all sorts of things inside our digital twin. So this is the effort that is currently ongoing inside Smart Internet Lab. The second one is spectrum management in future networks. So we are doing spectrum management through digital twin as well, where we would be able to, from controller side, we'd be able to manage the spectrum in a way that is informed based on the context that we receive from the physical infrastructure. What is the role of reality emulator? Of course, has a huge role. We will be able to test not only scenarios, but also interact with it, which is the unique capability that we have here. So we have a plan to start with the Matrix digital twin and test vulnerabilities of small services that we offer inside the Matrix. And also we look forward to create conflict arising from different AI models working together or working in silos to see how they react. So to summarize, the main takeaways from using digital twin as a cybersecurity enabler or network security enabler is that it will definitely disrupt the way that we think about security. And it will, of course, catalyze the best practices, but if not handled correctly, it will become a liability and it will become a threat, not only to the virtual infrastructure, but also the physical infrastructure as well. So there are numerous use cases for security, but the security of digital twin or physical system, that they are of course important, but the security of their life cycle, this digital and physical together, is more important than the individual ones. Thank you so much.
Any questions? I think we should start with the in-room questions and then I will see are there any online questions. Yes.
Please go ahead.
Yes, a question sparked off about your comment on fidelity. It struck me that different requirements of a digital twin might need very different fidelity models, and hence it's not a case of one physical model mapping to one digital twin, but potentially one digital model mapping to many different digital twins. And I just wondered about your thoughts about that and the complexity that would bring.
Thank you so much. That's a very valid and very interesting question. You're right that one physical model or physical system doesn't mean one digital twin. It could have many, as I said. The context is really important. For example, we ran into this scenario. We ran into this kind of problem as well, where if we have energy efficiency requirement in the network, there's one model that could, so we use in physical network, we use an AI model to let us know at which stage I can turn off one of the component that could save me some energy, right? But the same thing could be done by different models, different AI models, because one AI model doesn't, it could be done by a series of AI models, one AI model, and so forth. But the baseline that the system behave, for example, input, what kind of data is input to my network system, and what kind of processes are in there, and what kind of output do I need from them. That baseline remains same. On top of that, you can do with one AI model, with many AI models, even you can know through your digital twin that what you're doing in your physical infrastructure is not very good for performance. And if you do it this way, it would increase your performance. So you're absolutely right that you could have multiple models, or you can run different scenarios and simulations inside your digital twin to make that happen.
So my question was a bit more technical. So I was wondering what types of AI models did you use? Because some of the words you were using gave me some hints, but I'm not sure. And how, I mean, the cyber attack problem generally is a difficult research problem in my head. I've never worked with it, of course, but because a cyber attack is a random and kind of sparse event, so your regular flow of data is what you have most. So how did you deal with the imbalanced data set that you probably have?
Yes.
And how can you recreate or enhance that? How did you deal with that problem?
Yes.
In order to train effectively your models?
Yes, right. So as I talked about, this cyber kill chain means that what we do is that we try to analyze the network logs. So in the logs, if there's any anomaly, so we look for anomalies. This is the easiest way. Of course, more advanced, if you go more advanced, then it will be different. But if you look for anomalies, you can do any basic classification,
Like
any basic distribution. If you have anomalies, then you can look more deeper into it. If there's if there are any failed login attempts, many of them, that is one of the indication that something is going. So you can then look into that direction. If you have some other events that are not very likely, then you can look into that. So the AI models that we can use or will be definitely the same, as you said, where you can look into data distribution, you can look into classification and so forth. Or what you can do is that you can train on the existing data set that you can gather from your physical infrastructure or publicly available data set. Of course, I mean, they're not very trustworthy, but you can always look for imbalanced data set that your model understands, and it stands it out. Once you train it based on that, then you can, once you're certain that it will be performing in the way that you want.
What I find really challenging in this type of problem, of course, as I said, I'm not an expert on this, is that the cyber attacks, they always evolve. So they are quite dynamic in a way that you will train on one type of attack,
Yes.
but then something different will appear. So are you going to always need a human in the loop in order to signify that this new type of anomaly is actually perhaps a cyber attack before you start training? I mean, I don't know.
Yeah, no, very good question.
Okay.
There's one slide about it which I didn't include. Human, at least from my perception, the thing is that I think it is too soon to rely on automation. We are not there yet. So human will always be in the loop. The second question is really important. How do we know? So in the cyber kill chain, there are steps. First is reconnaissance. In more technical term, if you do port scanning, so if you see on your network port scanning, somebody's scanning your port, which port is open? So in the deception, what we then do is that we may make our one port open for example, DNS or for web services. So if we know that they're looking for that, you can understand the behavior a little bit in advance, what the attacker is then trying to do. So, but of course, that is not the entire story, but it's a good start. So it's very challenging.
Thank you so much, Rasheed. I really enjoyed that. Learned a lot, as always, listening to you. I appreciate this, and you'll obviously appreciate where I'm coming from with this question, but I understand the application of the digital twin in, rethinking the way we think about cybersecurity and, challenging and thinking about a best practice. But my question is, can we even take it one step backwards earlier to start thinking not just about how we can, think about replicating or simulating models and then think about security and embedding security through that approach, which you just beautifully defined. But can we go even a step before and think about creating different futures, if you like, different objects, different models, different ways of doing things, different systems? Is this too futuristic, or can we expect some sort of development in the digital twin world in that space?
Again, I'm so sorry I couldn't include one slide that should have been there. So when exactly do we create digital twin? When? The question about when is really important. It could be before, it could be even before the product, the system, or anything is designed.
Right.
You can use digital twin to co-design.
That is exactly what I wanted to know.
So based on historical knowledge, based on physics, based on experience, based on surroundings or anything, I mean, there will be something that is related to what you're trying to do. You can start with that, and you can co-design with digital twin. So digital twin doesn't mean that the physical asset is there and you're trying to mimic it. It could be very well before. Of course, then naming it a digital twin is
a little bit
a
yeah.
little bit weird.
Yeah.
But still, it could. The process of starting with a digital infrastructure. And I think that that is the right way. But since we can't, we can't help it but to think about the digital twin of existing systems, that's why it's more prominent.
Thank you. Great.
We have one question online.
Yes.
Thanks for the very interesting presentation. Is there any work combining the concept of models, shadows, and twins with high levels of segregation to help detect and prevent fault and/or malicious attacks? So we have a simulation, a reference environment, and map that tells between the model, shadow, and twin. Thank you for the question.
To my experience, these terms, that was the reason I talked about these different terminologies. Mm-hmm. The word digital twin is highly blurred, at least in the academia, because every second paper you look into, they call it digital twin empowered this. But yes, I've come across, at least from the academic side of it, there are works that consider intrusion detection, for example, threat hunting, and the threat intelligence bit. I used it in my research before. So there's a system called CM, which gathers data from everything. I think in our word monitoring, what we call monitoring, it can really help a lot in at least understanding the context of the system for us, the network. But there are works that covers at least the intrusion, anomaly detection, and attack hunting, looking for zero-day attacks and building up on that knowledge, and combining, we call it threat intelligence. So yes, there are some work. I'm not sure about the real-world scenarios. I'm not aware if any systems they use it, but I think reality emulator is the best place to start doing these experiments that we are currently. We do have digital twin model of our metric. As I said, we are planning to use it in a way that we can at least mimic these kind of attacks.
Thank you. Any other questions? Yes, please.
If a digital twin is only a twin in the sense that it replicates certain aspects of the physical asset, can we also say that digital twins are also the models we produce of organisms or agents that are dynamic and change within digital environments? So it's not a physical asset, but there's a model of how people interact with digital spaces, how they respond to marketing.
Definitely. Another good example is what I think Daniel would correct me is, if I'm wrong, the Harborside Festival use case. So Harborside Festival, that day we were thinking in our workshop about creating a digital twin inside Reality Emulator to try to co-design and co-plan the entire festival. So it's not only, I think, limited to any very technical components or systems. It's very much there for the processes and the behaviors, and you can even make a digital twin of a behavior rather than a system. Means that in that case, you don't have to replicate the entire system, but you have to you can only replicate the behavior, the way that system behaves. So it only gives you more space to work on. It's not a simple model that you make and do something with it. It gives you space to do many things.
Thank you. Yes.
Can I just want to pick up on that?
Yes.
Coming back to that, then, if your agent, we'll call it that, is abstract, how do you get your data flow from that abstract agent to make it a twin and not simply a simulation or a model?
Yes. I think the data initially it's really important. If you don't have the real data, as I would give the example of networks.
Yeah.
We really don't have data. That's why we have a huge setup in Smart and Lab where we have our own infrastructure from which we can derive the data and we work with the data, but it's not always the case. So in that case, I think AI these days, it's good enough. Generative AI, generative adversarial networks, GANs, are a very good example of generating the data in a behavior that you want. Sometimes it's out of control, but mainly I think they're now, I wouldn't say mature enough, but at a position where you can use the data generated by them, but not entirely dependent. You, at some point, I think, in order to work with real system, at some point, you really need data from your real system. You can even use the data to cross-check it with the data that is generated by either simulator or these AIs. So, yeah.
Yes, please.
My question's around verification. So operational systems and certainly safety critical systems have to go through very stringent verification processes. So the question then is there a role for digital twins in that? And then the supplementary question is, how do you verify a digital twin?
That's an excellent question. Shadi is here. We are already working on the verification bit. Yes, you're right. The verification requirements and these things are really stringent. That's why, from automation perspective, we are really far away. So no matter what digital twin does, it has to be checked, verified, either formally, informally. That's the choice you can make. But you have to verify it before you deploy it or before you send that decision. From our perspective, what we are trying to do is we have AI models that we use for different use cases. For example, energy efficiency, mobility, or traffic steering, how to steer the traffic between different access technologies. We do that model verification inside digital twin to make it trustworthy. But trustworthiness is another aspect where how exactly do you trust the AI model or the output? So one of the things that we do together with our partner is the formal verification of AI. And then there are other sorts of verification techniques as well that you can do, not only to the AI model, but the system as well. So I think that component, it should be inside the digital twin as well. Not only that, maybe you can verify one subsystem, but the integration of two systems, how they interact with each other should also be verified at a system level. So these are the caveats that we have to consider inside digital twin as well. Because at the end of the day, we are using these digital twin to have informed decision in our physical infrastructure. That would be network, that would be any other kind of infrastructure as well.
We have another question online. Thank you for the presentation. Has the Internet Web conducted any studies or published results on benchmarking the predictive capabilities of digital twins, identifying vulnerabilities or potential failure points, specifically in relation to digital twins fidelity?
Benchmarking on, sorry, I missed the second bit.
The predictive capabilities of for digital twins in identifying vulnerabilities.
I'm aware of some academic work. Academic work is there, but I think I can't verify it. There are works being done, but those are not, so those works, I think it's a very unusual way to say the simulation of digital twin. So simulating digital twin itself, that doesn't make any sense, but until and unless everybody has a capability like we have, it's always, in our research before we eliminated, we used Microsoft Azure digital twin platform, where they provide you with the drag and drop facilities where you can define what how your system is and so forth. There are other methods, for example, infrastructure as code, Terraform, Ansible, where you can use to at least architect the system, or you can use AI, GNN, graph neural networks, that identifies the relationship between different components. So coming back to the point, predictive methods, you always have to double check it or cross check it with your physical infrastructure if that is if that exists. So there are studies on the predictive analytics capability of vulnerabilities in cyber physical system, but on networks, I'm not very sure. For the use cases, for example, vehicle-to-vehicle communication could be one use case of 5G or beyond 5G networks. There are some cases, there are other cases for network slicing and so forth, but I'm not aware of any real-world use cases.
Okay, thank you so much. So thank you for your talk today. There are no more questions, I assume. You can have coffee, tea.
One question, sorry, Rasheed, sneaking at the end of a really complicated question. Tell me if this is the wrong way of thinking. But so in BDFI, we're sort of moving towards trying to figure out how to take on some quite big problems, solutions, and so on, right? And there's elements of your talk which I think are really interesting for thinking about that relationship between problems and solutions, right? Where we've got the potential for digital twin to be a solution to a problem, right? Like we might say, well, we've got a very complex environment, and so we're going to build a digital twin that will help us to solve. There's other bits where maybe we're looking at digital twins as a way to help us rethink what the nature of the problem is, right? So rather than just thinking about it as a solution, we're saying, what exactly is the problem here? And digital twins can help us define that. But then you also talk in your slides up there, I can just see at the top there, about using the digital twin just to disrupt all of our conventions for thinking about maybe problems, solutions, and what's going on. If we go down that route and we say, right, we want the digital twin to really help disrupt what's going on, what are the following steps after that? How do we then get back to saying, so these we've disrupted, what follows on?
Yeah. So I think the most important thing is the unknown unknowns. Mm-hmm. And it's very difficult to know those unknowns. And as Angeliki also mentioned, that these attacks that we talk about, there are actually, I don't have the exact figure, but there are millions of viruses, new kind of what we call zero-day malware or viruses every single day. Zero-day means that this kind of vulnerability or this kind of virus was not seen before. It's very new. So there's something called CVEs. I don't know what the abbreviation of CVEs is. There's a database, there are different databases. CVE is a number that is given to every vulnerability that has been found, and it's documented, it's there. And there are other databases where you can go and see all the vulnerabilities that are happening. What important thing that we can learn with digital twin is to sort of know the behavior that we might not know before. I mean, a simple AI model could do it, but I'm not sure if that would be capable. So the unknowns that we find through digital twin, probably, hopefully, we'll have new ways to think about how we can solve the problem. I would give the example of deception, cyber deception. Cyber deception is a really, really powerful tool. So it doesn't hide the fact that cyber attacks might happen, whether you like it or not. But how do we contain them? I mean, this idea of cyber deception was really cool for a long time, but we didn't have the capability. You might have heard of honeypots. So honeypot is a very abstract version of having a deception where you can, honeypot means that I deliberately create a database or a table with the name passwords and see who is trying to access that, and then from that point I can know that something is so deception, for example. We will have the capability to explore it more, how we can make our system more resilient. So I think it's too soon, at least for me, to think what more we can do, but I'm sure we can do a lot with knowing the unknowns. Yeah.
Sorry, do you mind if I actually jump in? Sorry I missed your talk. I had another event and didn't have a digital twin of myself, I guess. But I wanted to ask you about challenges, particularly in the telecoms industry. So, for example, in energy, where I normally work, the big challenge to the digital twins is the lack of asset visibility, of lack of the knowledge or data access in the industry, and there's this kind of old paradigm of security by obscurity, where companies are not willing to share data with other energy companies because there's this assumption that what's unseen, unknown, secretive is the most secure. And obviously that cannot be the case with digital twins, because you need to have the access to really good data and in a good timescale. So how does it work with the telecoms industry?
Right.
What was the conversation in the industry with regards to data access?
Right. Shadi, correct me if I'm wrong. I think we are lucky because most of the time in telecom industry, we work with open networks. And I think the setups or the components that we work with are fairly known. So the type of services that are provided there or how it is implemented, that bit is different. So the fundamental thing is sort of standardized. Sometimes it's a little bit out of the standard, but what you can do is that you can always know how the infrastructure will look like. As far as data is concerned, that is really a problem. I mean, we are lucky to have an infrastructure where we can have the real data from real network, but data is really scarce, at least in telecom industry, as in other industries as well. So I think getting quality data is as important as having a good solution. If you have a good solution, it's not trained on good and healthy data, it's really challenging. So yes, I think we share the problem of data scarcity in telecom industry as in other industries as well, but at least we have some baseline to work with.
Thank you so much. We have to wrap up. Thank you so much for your talk.
Thank you so much.
Please help yourself with a tea, coffee. Thank you.